So, piecewise functions, that's what these are here. That's what our lesson's on today. Last year, if you took Algebra 2 Honors, you did do this. Last year, if you took Algebra 2 Regular, you did not do this. So, I'll go over it as though it's new. But basically, what we got going on here is a function that is made up of multiple functions. So it's going to have multiple different shapes going on. These pictures up here are basically examples of what a piecewise function would look like. We've got this line going that way, this line over here, and this horizontal line right there. Notice they are functions. They pass the vertical line test. The regions don't overlap. Like there's a cutoff where, okay, we have one line to the left, one line to the right, and one line in the middle. And their equations, I'll just show you from the back page, could look like this or this. And so basically, what this graph is saying is, okay, for x less than -4, you don't have to do this one, just kind of watch here for a sec. For x less than -4, okay, we're going to have a parabola over here. It's going to look like that. For x between -4 and 0, I'm going to have my absolute value function. And then for x greater than 0, I'm going to have a parabola. And so that's kind of what our graphing process is going to be like. That's actually, there we go. Yeah, that's actually what this graph would look like. And so notice, like, we have very clearly defined boundaries up there that tell us exactly where to graph each of these shapes. And then we end up only graphing sort of part of each shape as it would appear on the graph. So we'll start with easier ones than that, but that's the idea. So what this one is saying is for x less than 3, we're going to graph y equals -4. What does y equals -4 look like? Yes. All right, that's a nice horizontal line at -4. And that line exists up until x equals 3. So I'm putting a little open circle there. And so that's like our first region. And then for x greater than or equal to 3, we're going to graph y equals 2. So y equals 2, also a horizontal line starting at 2. This one gets a closed circle. And it gets a closed circle because exactly greater than or equal to. Okay, so very simple one. So let's look at 14. One thing that I like to do when I'm doing this is I like to draw a vertical line at whatever the boundary is. Dotted line, vertical line, doesn't really matter. This is not an asymptote. This is not part of the graph. This is just like a visual marker for me to remember where I'm supposed to stop. And a lot of times I will write above or below that region what graph is supposed to go there. This is just because going back and forth between the graph and multiple equations can, I don't know, it can get confusing. So I like to just like label it, put it over there. I'm a very visual person, so I like to just have it organized visually. So for this part of the graph right there, what is the y-intercept of 3x plus 2? 2. So there's 2, and then the slope is 3. So that means up 3 over 1. So I'm just going to graph that. And I'm going to put an open circle there on that line. Now, normally this line would continue that way, right? But we're going to not include that part of it. We're going to stop the line right there at our boundary marker. It gets an open circle because it says strictly greater than -1. Our line stops right there. Graph it right, actually. Stands out a little more against the background. Okay. Now notice for that line, we have the y-axis, which is right here, inside that graph's region. So it was really easy to put the y-intercept on the y-axis because we had the y-axis. For the graph to the left, it doesn't include the y-axis, so we're not going to be able to just plot the y-intercept. What I usually do when I graph is I still go to the y-intercept, which would be -2, and I kind of just mark that point right there. And then I have a slope of 1, so that graph's supposed to be over here in this region, so it doesn't really make sense for me to graph it this way because that's not where the graph goes. I would just trace the slope back here, and then graph my line, and then put a closed circle on the boundary, and then I just erase this part. So I just go to where the y-intercept would be, and then just count backwards or forwards to put it in the region where it belongs. But that's not the only way to do it. That's the way that I like to do it. The other thing that I could do is, if I want to know exactly, if I want to just start on the boundary line, where x equals -1, how could I figure out that point without graphing it first? How could I figure out the y-coordinate with that? Follow. Yes. We put -1 into this. And again, we want to do it for the equation that we're trying to graph. So that's another way I could do it. When I plug in -1, I get -1 minus 2 is -3. Okay, that tells me put this point right there on my boundary line at -3. So that's the other way to do it. And of course, you could always do it both ways to check. Okay. Let's look at number 17. Okay, so again, I've got my boundary lines at 3 and -1. I'm going to label those regions. That step's not necessary, but I find it to be very helpful. It doesn't matter which one you start with. I might start with the middle one because that's the easiest. That's just going to be a horizontal line at -1. Would that one get closed circles or open circles? For -1. Open, yeah, so I'm looking at that region right there. Open circle. Open circle. It's a pretty exaggerated open circle. Okay, so we'll look at both ways. If I take this one right here and let's say I don't want to do the y-intercept way and trace it, I just want to figure out exactly where it hits the boundary line. I'm just going to take 3, the boundary x value, and plug it in for x. What do we get when we plug 3 in for x in that equation? Yeah, we get -1. Okay, so that's going to go right over top of this open circle. Basically, it's just going to fill it in. So we actually don't have an open circle there anymore. From this point, the slope is -1. So I'm just going to go down 1 over 1. And then for our last piece right there, 2x plus 1, let's say I'm going to do it the other way. What would the y-intercept of that line be? Y equals 2x plus 1, what's the y-intercept? 1, right? 2x plus 1, y-intercept's 1. Okay, so the y-intercept would be 1 right there. And my slope is 2 over 1, so my line would look like this. Okay, notice we're closing that open circle. And I'm just going to erase the part of the line that is in the wrong region. So we end up with that. Kira. That's 2. So the +2 is the y-intercept. The y-axis is over here. So if I were to continue tracing, that line, it would hit 2 eventually. Or it would hit. Did I graph this wrong? Oh, no, yeah, it's right there. I was looking at the dark one. Yeah. That's where it would be if it was the full line, but we're cutting that part of it off. So yeah, these numbers in here, these are not shifts. What they are is the equation of the line with the slope and the y-intercept, and we are only graphing part of that. And so again, we can either plug in the number to figure out the point, that's what we did for this one, or we can go to where the y-intercept would be if it was the full line and graph and then erase the part that we don't need. Other questions? Okay. You guys are going to do numbers 15, 16, and 18. Ready, set, go. Okay, here's what I got for 15. Something unique about this is that they are line segments, they're not lines. They both have finite restrictions there. They both go open circle, closed circle. 1/2 x plus 1, yes. So for 1/2 x plus 1, again, the way I do it is I would go up to 1, the y-intercept. Oh, I'm going the wrong way. That's, yeah, so it's wrong. So then I would go up 1 over 2, and I should be going this way. There we go. Good catch. I knew something was right. Okay. Here's number, I guess I'll just do 18 because it's straight down. Number 18 is a little crazy looking. Check and make sure that I did it right. Good. Got a little line segment in the middle. I'm just going to shade the y and x axis here because they're kind of hard to see. Questions on that one? The middle part, yeah. So the middle part's 2x plus 1. So I do have the y-intercept because I have the y-axis. So there's my plus 1. And then my slope of 2. So positive slope, remember, is angled like this. So my line doesn't go to the right really at all. But if it did, it would go up like that. So instead, I got to go down 2, back 1. Down 2, back 1. When I hit that -2 boundary line, I have to put an open circle. Yeah. Great. All right, and then there's number 16. Question on that one? Okay, let's go to the extra page that I gave you guys. The very faded one. Again, apologies for that. Our copier is struggling. So I would definitely recommend just like tracing over that graph so you can see a little clearer. And what I would do too with those lines is like mark off some points that you see just to check on the slope of those lines. Okay, so we're going to write the equation for these graphs. So remember the way this divides up is the equations go here on the left side, and then the region where it is over here. So for this first part, this horizontal part, what would the equation of that be? What would the equation of the horizontal line be? Y equals 6. Yeah, right, y equals 6. Okay, so we have the y equals already. We have f of x equals. So we're just going to put 6 up here. We're going to put a comma. And so this would be for x less than -3. Strictly less than because we have an open circle. I'm going to erase that line. That line doesn't work. Yeah. Okay, for the next part, what is the slope of this line? What? 1. The next line. -x plus 3, yes, would be the full equation. Yeah. Slope of -1, y-intercept of 3. And then for the region, -3 is less than x. And now actually we have some options here. So we have some options of how to write this, because right here at 0, we have a closed circle. But we just have one closed circle. So what we're not allowed to do is this right here and make them both equal to 0. If we do this, we are technically failing the vertical line test because we have 2 points over top of each other, which we're not allowed to do. So the only rule is just one of them has to be equals and the other one needs to be strictly greater than or strictly less than. But it doesn't matter which one. So I could do this. This is option 1. And then option 2 would be that. And it really doesn't matter. There just needs to be exactly one equal sign on 0. You can give it to whichever equation you think deserves it more. Then for that last line there, what would that equation be?
So 1/3 x plus 3.
Close. I would say the slope is,
Oh, 4.
yeah, 1/4. Okay, questions on that? Okay, now that one is a little easier because both of these lines here and here, like we can see the y-intercept of both. So it gets a little trickier when we have a line just kind of like off in space over there, and we're trying to figure out what the y-intercept would be, but we'll talk about that in a sec. Okay, you guys do number 20. Okay, so I did the regions here for number 20. What is the one thing that I could change about the way that I've written the regions here? Okay. Could I change all of them? Yeah. Which one could I change? Yes. Could put it there, and then take it away from there. Yeah. The rest of them have to stay because we have open circle here and there. Nice. Okay, so again, it doesn't matter whichever one you want. What do we get for the first region? This slanted line here. What do we get? What's that? 1/2 x. Did you guys get 1/2 x? Okay. And then for the second region, 2, and the last one, 6. Not too bad, right? Questions? All right. So again, another one here where the line that has a y-intercept is going through the y-intercept, so it's easy to come up with that equation. Let's look at 21 here, where we have a few lines that don't go through the y-axis. A little harder to figure out the y-intercept. So let's say for this first one here, first of all, make sure that you're putting your regions in order. So we need to go left to right. So we would start with x less than or equal to -3, I guess. Starting with that point. So for this one here, what I'm noticing is a slope of 2/3. So one option I have to figure out the y-intercept is I could just keep counting and see where it would hit the y-intercept. This works about half the time. So the equation of that line is y equals 2/3 x plus 10. About half the time, though, you kind of intersect in a weird like fraction points. And so you can't always just trace the dots like that. So the way that the way that always works is you can pick any point on the line. So if we're looking at this middle or this like second region here, I've got 2 points that I could use. So that's this one or this one. And we're going to get the same answer either way we do it. So I could think of this first point as being shifted from the origin. So I'm thinking like I'm transforming a graph, I'm moving it, shifting it. So either way we do it, we have to use the slope. The slope is -1/4. But then if I think of this bottom point here, if it was shifted from the origin, it went left 2 and then up 4. Do you agree? Left 2, up 4. So we have x plus 2 to go left 2, and then plus 4 on the outside. Notice I still have to use the slope. These are my rules for a transformation form. Got like a vertical flip, compression. Sorry, not 1/4, 4. -4. I've got a vertical stretch. And I'm going left 2 up. Again, we don't have to do it at that point. We can do it at the other point. So that top point, which way was that one shifted? If it was coming from the origin. Left 3. Up 8. Okay. So I still need the -4 on the outside, but we're going left 3, up 8. Or, I mean, again, we do have the option to just trace down to the y-intercept. I see the y-intercept is -4. So no matter what, I should be getting -4x minus 4. But again, it's not always nice and easy to trace the points down to get the y-intercept. Either one I do up here, if I distribute that, -4x minus 8 plus 4, that equals -4x minus 4. Or if I do this one, distribute that, that's -4x minus 12 plus 8, that also equals -4x minus 4. So I'm getting the same answer, but just in case, like for this one here, this one would be really hard to trace down to the y-intercepts, right? I'm going to run out of room for that last one. So we can use this transformation form. Okay, then obviously that one's just 4. Okay. Questions on how we got those points there? Okay, you guys do it for that one if you have not already. The slope of that one is 6. Okay. So again, for this one, it's not impossible to just count down to get to the y-intercept. My slope is 6. From this point here, I need to go over 4 times. So I'll go down to -2, and then -8, and then -14, and then -20. So I can get 6x minus 20 by just tracing those points. It's not always going to work out to be a whole number. So we just need to have another way to do it in the event of that. So this point right there, I could do 6 parentheses x minus 4 plus 4. Or I could do the top point and say 6x minus 5 plus 10. Both of these, when you distribute, you get 6x minus 20. We do have to write it in y equals mx plus b form. Like, that's the correct form to write the equations in. Here. So I did less than or equal to -3 for the first one. So then this -3 needs to be an open circle. Then my -2 was a closed circle, so this -2 needs to be open. This -4 was closed, so that -4 needs to be open. So I can only have one equal sign for each number, but it doesn't matter which one. The region or the graph? Yeah. Oh, yeah, it is 5. Yeah, it's not 6. It's 5. Yeah. Sorry, guys, that last one should be 5, not 6. I was thinking 6 because of the slope. Struggling. Okay. Other questions? Okay, that's it for part one. Next class we'll do this with like parabolas, square roots, absolute value functions, etc.